In this video, I'm going to demonstrate how to take the derivative using implicit differentiation. So far, we've been able to take the derivative of quite a few things. We can, based off of operations like adding and subtracting, you can take the derivative of functions. You also have learned the product rule, you've learned the quotient rule, and you have also learned the chain rule. However, all of those were based off of functions. So what happens if it's not a function? For example, in the past you have learned what is a function, not a function, based off like the vertical line test. So if you were to draw vertical lines through a graph, if it crossed more than once, it would be considered not a function. So what sometimes you can do in this function is you can break it into two functions to find your answer. For example, x squared plus y squared equals 25. It is not a function because it is actually a circle, and if you do the vertical line test, not a function. And so if you were to solve for y, then you would have to subtract x squared. But then when you get rid of the square by taking the square root, it becomes a plus or minus. And why? Because the positive of it would give you this arc. The negative would give you the bottom arc, which if you were to put them together, that's how you actually got the circle. And so what to do when this happens is a lot of times you will not be able to solve for y. In the case above, we were able to solve for y, but we still had to break into two functions, the positive and the negative. But there's going to be cases to where it's impossible to solve for y, okay, because they are going to be stuck in two different terms that you can't factor them out of. And so to do something like this, if you were to do a vertical line test, it would fail in a couple of different places. Basically, in time between 0 and 3, it would completely fail. So you would have to break it up into different functions that you could be able to take the vertical line test to work. Enter implicit differentiation. And so here is how you're going to do it. You are not going to solve for y in order to solve this. Okay, you're actually going to differentiate, meaning, okay, in the past, it's always been some type of function, but it was always equal to y, which means all we did was to find the derivative with respect to x. We would just take the derivative. It would be 6x plus negative 3 sine x. Okay, you would take the derivative of the x's, and the derivative of y is literally the derivative of y. Or we could say y prime, same thing. We're going to do the same thing here. And when we get to the y, you have to consider the y to become a chain rule. Think of y as a function. So I'm going to take the derivative with respect to x. This is important because whenever we get to something that has to do with a radius, it would have to be with respect to r. If I was doing a derivative with respect to time, then you would take the derivative with respect to t. So x squared becomes 2x. Now y squared, think of it as being any type of function. This is where the chain rule is going to apply. So you're going to bring the 2 down front, so it'd be 2y, but then you got to take the derivative of the inside. We don't know the derivative of y, which means we got to keep it as just y prime. And the derivative of 25 is 0. Now, solve for y prime. And so I got to subtract 2x. And I'll get negative 2x. And now I got to divide by 2y. And reduce. So the derivative is actually going to be the function negative x over y. And that is going to be actually be my answer. So now the derivative is no longer a number. The derivative is actually going to have a 2-variable equation in it. So in this case, we are going to solve with respect to x. So the derivative of x cubed is 3x squared. But think again of y as being some function that's cubed. So I'm going to bring down the 3 and make it squared. But then I got to take the derivative of that y, which we don't know what it is. So I just got to actually write the derivative of y. And now in this case, on the right-hand side, this is the product rule. So think of it as 6x times y. So I'm going to take the first times the derivative of the second, which we don't know the derivative of y, so we got to actually just write derivative of y. Plus the second term divided by, times the derivative of the first. The derivative of 6x is just 6. So now we have our equation that has now been derived. Now I need to find my y primes. All right, I have a y prime in this term. I have a y prime in this term. So I'm going to get everything I'll get y prime on the left. Okay, so I am going to subtract 3x squared. So I'll get 3y squared times y prime equals 6xy prime plus 6y minus 3x squared, because I subtracted 3x squared from both sides. Now I need to get the y prime over to that side. So I got the 3x squared over there. Now I need to get the y prime over with the other y prime. So I'm going to subtract it. So I get 3y squared times y prime minus 6xy prime. Okay, I got it over to the left. And on the right-hand side, I have a 6y minus 3x squared. Okay, they are now on the same side. So now, factor. So I'm going to pull a y prime out. And I'll be left with 3y squared minus 6x. And now to solve, I got to divide, because that's multiplied. So therefore, my answer is going to be 6y minus 3x squared divided by what I divided both sides by, which is 3y squared minus 6x. And there's your answer. The only other thing technically you could do, if you wanted to, is you could pull a 3 out front. And then know that 3 divided by 3 cancel. So your final answer would just be 2y minus x squared over y squared minus 2x. Could be your final answer in the same. So we're now going to do the same thing, except now we're actually going to find the equation of the tangent line at a certain point. So I graphed this and then found at 3, 3, I found the tangent line. And I want to know, what is that equation? This right here, the equation of the tangent line. I want to know what that is. So what we're going to do is I'm going to bring down the fact that I know the derivative is 2y minus x squared over y squared minus 2x. I know that that's the derivative. And now I'm going to plug in 3, 3 to get my slope. Because remember, derivative means slope. So I'm going to plug 3 into y, 3 into x, 3 into y, 3 into x. So on top, I will get 6 minus 9 squared. No, 6 minus 9. And on bottom, I will get 9 minus 6. So I'll get a negative 3 on top and a positive 3 on bottom, which is negative 1. That is my slope. So I know the slope of this line over here is negative 1. So therefore I know that is negative 1x plus b. And to find b, I'm going to use the 0.33 again. So I'm going to plug 3 into y and 3 into x. So I'll get 3 equals negative 3 plus b. So b equals 6. And therefore my final equation is negative 1x plus 6. And again, that represents the equation of this tangent line. So let's try a couple of problems. I want you to pause the video, attempt to do this problem, and then hit resume to see the answer. Okay, left side, this is a product rule. We have x times e to the y. So we got to find the derivative of that. So I'm going to do the first times the derivative of e to the y. Well, the derivative of e is just e, so it's e to the y. But then I have to take the derivative of the exponent, and we don't know what it is, so I have to leave it as the derivative of the exponent. And then I'll do the second times the derivative of the first. The derivative of x is just 1. Now the right-hand side, the derivative of x is just 1. We do not know the derivative of y, so I got to actually bring down literally the derivative of y. Now I'm just going to clean this up. I'm going to get rid of the parentheses. So this is going to be x e to the y times y prime plus e to the y equals 1 minus y prime. Okay, so I have a y prime here and I have a y prime attached to this. So I'm going to try to get the y primes on the same side. So I'm going to get x e to the y times y prime. That is a minus, which means I'm going to add y prime to the left side. Okay, so I have y primes together, but I got to get rid of everything else. So I only want the terms with y prime being on the left, which means I need to get e to the y over there. So I'll get x e to the y prime plus y prime equals 1 minus e to the y. Now I have y prime on the same side and I can factor it out. And if I do, I'll get x e to the y plus 1 because I factor the whole thing out, which means I have to have a placeholder, equals 1 minus e to the y. And last, I got to solve, so I'm going to divide by the parentheses. So my final answer is going to be 1 minus e to the y all over x e to the y plus 1. Okay, so let's work on some that have trig functions in there. This is where, again, you're going to have a chain rule because you're going to take the derivative of the outside of sine, then you're going to take the derivative of the parentheses. So first take the derivative of sine. The derivative of sine is cosine, so rewrite it as cosine. Now you got to take the derivative of the inside. The derivative of x is 1, and the derivative of y we don't know, so we're going to have to actually bring down literally the derivative of y. The right side is also is a product rule, actually. So this over here was a chain rule. This is a product rule. So the first times the derivative of cosine, which is negative sine, plus the second times the derivative of y squared. Well, y squared becomes 2y, but then you got to take the derivative of y, and we don't know what it is, so we're going to have to bring it down. Now, from here, it is basically just cleaning up. So I am going to distribute my cosine times 1 and my cosine times y prime. So cosine of x plus y times 1 is just cosine of x plus y. And I'm going to multiply the cosine of x plus y times y prime. And then this would be negative y squared sine of x plus, I'm going to bring the 2y in front. Okay, so I got to find my y primes. All right, I have a y prime in this term. I have a y prime in this term. I got to get them together. Doesn't really matter how you do it, but I'm going to get them on the left. Ooh, sorry. I'm going to get this one on the left, and so that the y primes will be together. And I'm going to go ahead and get anything that's not y prime to the right. So I got to get this to the right. So I'm going to have cosine of x plus y times y prime, that's this part right here, minus, because I had to subtract, 2y cosine of x times y prime. Okay, I got this over here on the left, so these two, this one is that one, and this one came here. Okay, too many arrows. And on this side, I'm going to subtract cosine of x plus y. So I'm going to bring down my negative y squared sine x, and I'm going to subtract cosine of x plus y. Okay, y prime, they're on the same side. I can now factor them out. So I'll be left with cosine of x plus y minus 2y cosine equals this. And now solve by dividing by the parentheses. So my final answer is going to be all over that. Fun. Okay, side note. Depending on where you learn this in pre-cal, or depending on which pre-cal book you used, or even which calculus book you're using, you're either going to see an inverse function either written like this, or it's written like this. Okay? Now, in the past, you learned that x to the negative 1 is the same thing as 1 over x. Okay? In terms of trig, that is not the case. It actually is the inverse. And what the inverse means is, like, if I said that sine of theta equals like square root of 2 over 2, in order to solve for theta, you have to take the inverse. So you would do the inverse of sine of square root of 2 over 2 would equal theta. That is actually what an inverse does, is it helps you to take basically the reverse order. You're taking the inverse of something in order to work backwards to find your original angle. Also, when you do an inverse of a trig, remember how we discussed at the very beginning of this video, which feels like forever ago, that you cannot have, you can't take, it's really hard to take the derivative of a function. I'm sorry, it's hard to take Okay, at the very beginning of this video, we discussed that you have to use implicit to take the derivative of things that are not functions. And if I was to graph a trig function, like sine is a wave function, and if I normally would graph the inverse of it, it would look like this. But we discussed the fact that you cannot have, if you did the vertical line test, it wouldn't work. If I did vertical lines, this would not be a function. And so what happens is that you have to stop a sine function or a cosine function in order for the vertical line test to actually apply. And so the inverse of sine actually only works from negative pi over 2 to pi over 2. And a cosine only works from 0 to pi. Tangent, cotangent, cosecant, secant, all are going to be the same thing. So just understand that they had to basically bound, or they had to isolate the domain, or restrict, I guess, the domain for it to remain a function. The derivative of these trig inverses is this table. So just Reference this table anytime you need to find the derivative of one of these inverses. So in this case, I need to differentiate 1 over the inverse of sine. Well, here's what I'm going to do. I am actually going to rewrite it. We know that 1 over sine is the same thing as cosecant. So I'm going to rewrite this as cosecant inverse. And so the answer is automatically going to be this right here. Now, in this case, u is going to represent any function that's there. So therefore, I know that my answer is going to be negative the derivative of x, which is 1. And on bottom, it is going to be the absolute value of x multiplied by the square root of x squared minus 1. So in this case, this is a product rule. You have the square root of x multiplied by arctan of 3x. Now the first thing I'll do is go ahead and write down what the derivative of arctan is. Okay, arctan is going to be this formula, u prime over 1 plus u squared. So I'm going to go ahead and write that. U prime over 1 plus u squared. All right, so here we go. Next thing I'll do is instead of the square root of x, I'm actually going to do x to the 1/2. So if I know that in arctan u equals 3x, then I know that u prime, the derivative of 3x, is just 3. So I'm going to use that whenever I need to get to this formula. So here's how we do it. First, product rule. So first times the derivative of arctan. Well, arctan is u prime, which we know is 3, over 1 plus u squared. U is 3x, so 3x squared is actually 9x squared. Make sure you square the 3 and the x. So that was first times the derivative of the second, plus the second times the derivative of the first. The derivative of x to the 1/2 is 1/2 x raised to the negative 1/2. And now from here, all we're going to do is clean it up. So the square x to the 1/2 is in the numerator with the 3, so I'm going to keep it, and I'm going to go ahead and bring it back into the square root of x. And the denominator is going to be 1 plus 9x squared. Plus, arctangent is in the numerator, so I'm going to go ahead and keep that in the numerator. And then the 2 is in the denominator, and x to the negative 1/2, that negative means it also gets put in the denominator, and that would be your final answer. So last problem, if you want to go ahead and pause the video to attempt this problem and then hit resume when you would like to see the answer. Okay. Let's start with the left side. Derivative of x squared is 2x. Derivative of y squared is 2y, but we also had to take the derivative of y, which is y prime. Now this is chain rule, which means I'm going to take the exponent, bring it down front, rewrite everything, and then 2 minus 1 is just 1 or nothing. But then I got to take the derivative of the inside. The derivative of 2x squared is 4x. The derivative of 2y squared is 4y, but you also have y prime. And the derivative of minus x is just minus 1. Okay, at this point, we have now taken the derivative. Now, we could go ahead and solve for y prime. That's going to look really ugly. Thankfully, we actually don't have to do that. Why? Because we are only needing to find the equation of a tangent line, which means at this point, I actually can go ahead and plug in what I know. So that's actually what I'm going to do. I'm going to go ahead and plug in this point. Then I'm going to solve for y prime to find the slope. So I'm going to plug in 0 for x. I'm going to plug in 0.5 for y. Got to keep the y prime. Same thing. 2 times 0 for x. 0.5 for y. 0 for x. Same thing. 4 times 0 plus 4 times 0.5 for y times y prime minus 1. And then this is where it gets a little bit easier. Obviously, that goes away. 2 times a half is just 1. And then, same thing here. 2 zeros squared go away. This 0 go away, leaving me with 2 times 2, which is 4, times 0.5 squared. And then that is multiplied by, that goes away, times 4 times 0.5 y prime minus 1. Now I can clean it up. 0.5 squared is 0.25 times 4 is actually 1. 4 times 0.5 is 2 minus 1. So I have y prime equals 2y prime minus 1. So I'm going to subtract 2y prime, and I get y prime is 1. So I now know my slope from that. And now I know y equals mx plus b. And I know that my slope is 1. And now I can plug in my point. 0.5y, 0 for x. And so therefore b equals 0.5. So my final answer is 1x plus 0.5.